So from the get-go, when I started put this together about emissions, there was a couple reasons, because emissions, including myself, it gets a little complicated. It isn't complicated, but what makes it complex is that if you work at a dealership, say you work strictly on Cummins or whatever the case may be, or strictly on Freightliner, that's one thing. But if you guys watching right now, if you're like a repair shop that one day you're going to have a Hino in, you're going to have a Isuzu in, you're going to have a Mack in, you're going to have a Volvo in, you're going to have a Cummins, you're going to have a Detroit, you know, and again, a lot of the PACCAR products, it's a little complicated, you know. So the way I wanted to approach this emission, this particular part one, is I need to do it kind of generically to have some commonalities, and there's some huge commonalities. It will be a part 3, because one thing I realized, absolutely I cannot get into everything. So there's going to be a part 2, there's going to be a part 3. Part 2, I'm going to get into turbochargers, I'm going to get into EGR, and chances are the good portion of the diagnostic real world stuff will be part 3. But the reason I started with part 1, I'm going to keep it kind of like not simple, but when I do diagnostics, the one thing I always try to push is, you know what, if you get in a vehicle and you're not comfortable with what you're doing, you gotta figure out the description and operation. You know, whatever method you have to go online, that's the first thing I hit. Because unfortunately, sometimes, as smart as we are, there's so many strategies, especially today, between the ECM, between the BCM, and if one thing sees another, there's going to be a default because the strategy calls for it, and it'll do something different in the ECM, and before you know it, you're all over the place. So I figured, let's start from the beginning, and I'm going to get right into it. So let's get into this. Again, diesel emissions, usage, 3 parts to this. Oh, by the way, thank you, Dorman, for, in case I forget to say it, for allowing me to do the heavy duty side of it. G. Truglia, that does most of the automotive stuff, he got me on board about a year ago, because we are lacking, we don't get as much training or education on the heavy duty side that's possible, and I was over at the TSD big event, and I ran into Mike Cordoba. He's been following forever. There are a few guys from Canada, and we had some good conversations, you know, and we're all in the same boat. So don't worry about that. You know, that's just me. Again, I say it every time. What matters is, you know, what can I come up with? You know, what can you walk away with? So 101. What are we going to do today? We're going to provide insight to emission systems that are used on heavy-duty engines. Not just heavy-duty. It crosses over into medium-duty also. We're going to look at why we have emissions reduction. We're going to try to describe the key components in emission systems and how they work. So again, part 1, don't get discouraged. If you're one of those guys, you're so comfortable with it, it's okay. It'll be a good refresher for you guys, okay? But this part 1 will get us familiar with component systems required for diesel emissions reductions. Okay? Each time, each part, like you see it up there, we are going to dive deeper. Now, why do we care about emissions? What do we know about emissions? How can we control emissions? And basically, that's what we're going to try to cover today. What types of emissions are produced by diesel engines? They emit significant amount of oxides of nitrogen, NOx. Everybody's comfortable using the word NOx, and of course, particulate matter. That's been my gosh, that's an issue all by itself. I'm sure I'm preaching to the choir of these vehicles coming in. They go into D rates. You can't regen them, and I mean, it's a huge area. To be honest with you, a lot of that problem happens to be with maybe proper maintenance. Drivers not getting educated either, that, you know, hey, you know, maybe you should have stopped and tried to put a reach in, but we'll get into all that stuff. Now, however, compared to gasoline-powered engines, the lean, and that's a key to why we do things a little different with the diesels. The lean diesel air mixture results in smaller volumes, hydrocarbons, and carbon monoxide. So, as far as the diesels go, that is a benefit to it. However, combustion, because due to combustion, we're going to have high combustion temperatures, and that's going to result from compression ignition. You know, we got an air pump, you start squeezing something, you're going to really generate some heat, which is beneficial as far as the way the diesel works. You inject a little diesel fuel, and boom, off you go. You don't need a spark plug. But however, the issue is it does increase NOx formation, okay? So lowering the combustion temperature decreases NOx levels, but it's a balancing game. It tends to increase the amount of fuel which is not burned. And of course, if it's not burned or partially burned, it's gonna wind up with some particulate matter and unburned hydrocarbon emissions. Before I get into it, and I'm quite sure, you know, everybody knows the why would you want to have a diesel? All day long, they're efficient power plant. They have, again, you got to consider the mass that you're trying to pull. If you do that portion of it, you know you're going to get superior fuel economy. They emit extremely low concentrations of HCCOs, we already talked about. What about NOx and carbon dioxide? Carbon dioxide, CO2. Okay? Now, that tends to be the issue because right now, as we're speaking, the whole world is concerned about the greenhouse gas. Okay? And of course, they look at that being responsible for global warming. And those of you that live in the different parts of the world or country over here, you know you've been affected. I mean, the warming trends, the fires, the floods, you know, we're pretty lucky here in Buffalo, to be honest with you. We're kind of, I shouldn't say immune. So by the way, we're looking for people to move up here. So, you know, we're an ideal location for that. But let me get back to subject here. Just so you know, transportation-related CO2 emission represent about 30% of all man-made CO2. And I mean, transportation, let's face it, everything in this country moves on trucks. This is taken from the 2022 estimate, CO2 carbon produced from U.S. gasoline diesel fuel consumption. And I don't want to spend much time. You have it in your handouts, okay? You look at the metric tons of gasoline, of carbon dioxide that gets spewed out, diesel. And the thing is, the problem we have that for years, when I did a lot of automotive training, what I would say is that, you know, one of the things, if you use 4 or 5 gas analyzers, if you look for a high carbon dioxide reading coming, that vehicle was running very, very efficient. So it's kind of like try to balance this out. I'm running very efficient because of computerization and everything else, but now I'm putting out carbon dioxide. So it's kind of like a contradiction. So we want efficient running vehicles, but we need to reduce the amount of miles that the vehicles get per gallon, and that helps to reduce the carbon dioxide. But anyway, you got that over there. Just so you know, okay, this I just ran across this last month. The EPA's, they call it the Phase 3 greenhouse gas emissions. And part of that is the part of the Clean Truck Plan, that's why I picked out of there, more stringent standard requirements for manufacturers. And basically it says by 2032, they anticipate 25% of new long haul, 40% of heavy duty short haul medium vehicles to be zero emissions. Now, the industry, I will be very honest with you, they do oppose it. I mean, because I don't want to get into too much conversation in here, but one of the reasons we oppose it is it's coming awful fast. So it's like, can we be ready? Is it affordable for us? And first of all, the infrastructure isn't ready either. It's kind of like putting the cart before the horse. But the anticipation is that it will happen. So here we have the industry opposes, but just so you know, there's some manufacturers, others like Cummins and Ford, that don't oppose it. They do say, they made a statement, it is going to be challenging, but they can overcome any challenge to achieve that goal. And I will give you my 2 cents in here. And I truly believe that we have a country, you challenge us, we will make it happen. We made it happen in the past. We're the best, biggest technical country. If we put our mind to it, we will happen. And I'm proud of that fact. So let me move on here. Industry statistics, not even going to spend much time, but just so you see the amount of registered vehicles out there, single units, combination, vehicle miles traveled by all vehicles, large trucks and so on, and just do the little bit of a math. Figure if you're doing 20, 30 miles per gallon, it will tell you exactly how many billions and billions of gallons of fuel we use. So that's enough with that. Now, the way we got into this was when we first got into emissions, and I lived through the whole gambit with cars transitioning over to diesels and everything else. The way we got into it, we needed to have a baseline, and this was one of the first baselines, kind of like, okay, this is where we're at. Can we improve with this? And if you notice underneath there, look at the table, HCCO on engine out is lower in diesel versus gasoline engines. Even diesel engines out are almost 1 gram per brake horsepower per hour, less than the corresponding gasoline and diesel. And the reason I put that in there, I put the question, why? The 3-way catalytic converter allows the same gasoline engine to emit extremely low. So for us on the gasoline side, those cats did a wonderful, wonderful job, okay? So with the 3-way cat, we were able to reduce HCCO and NOx at the tailpipe. Okay? Now, for years, when I was in automotive, I had to get into stoichiometric and, all that stuff and everything, and emissions came up, and we were pretty lucky in New York State. We had a lot of programs because we didn't look at just doing emissions testing. We looked at if a vehicle comes in, it's a no-brainer how to test a vehicle, but how do you repair it? And even in the day, we figured, you know what, if you're going to prepare it correctly, you need to understand the chemistry, and so on. Because don't forget, the trucks are no different than cars. Everything you have on the truck, all your sensors and stuff, you're looking at that slide right there. You're looking to reduce all those emissions, okay? And if you look at that, one of the problems we have is, and let me see if I can get this little clicker going here, right here. If you look at the box over here, basically this is that range that's stoichiometric, and if you line everything up over there, you see on the bottom, it shows you 15.1, okay? But it tethers back and forth a little, but you can see all the different gases, okay, where they fall in line. And I put an error, look how high NOx is on the lean side. Well, guess what? Didn't I just say that the diesels are very lean running engines? And by the way, if you see over there that CO2 at blue, that blue line over here, see it right there? Look how high CO2 is, and that actually proves it. It's like the more efficient we are running down here, everything is down, CO2 is gonna be up. Okay? Now, particulate matter. This is the one thing that everybody, not us guys, we kind of grew up with it, but people for years, they see that black smoke and it was kind of like, oh, this can't be good. Well, to tell the truth, it isn't. When I first started out, that black smoke was huge. I mean, when I came back, one of the first jobs I had when I got back from Vietnam and got out of the Marine Corps was working at a trucking company. And every day the sides of the trailers, they had to get scrubbed because, I mean, these diesels were running rich. When's the last time you see a trailer going down the road and you got those black streaks and the whole side of the trailer's back? You don't hardly see it anymore. So we really have come a long, long way. But in reality, emissions suit also consists of other matters, unburned fuel, sulfur, and so on, okay? Now, the regulated emissions, diesel particulate matter, also referred to as particulate matter. total particulate. It's regulated by the mass of emitted. We already talked NOx is huge, nitrogen oxide, hydrocarbons, okay? And there's other things. I don't want to make this a chemistry class, but of course, carbon monoxide. Now, the particulate matter NOx, they truly have been, they are the primary focus of diesel emission control technology, excuse me. I'm not even going through the list, but if you have the handout, you'll see some unregulated emissions and stuff that comes out also. Now, the composition, what goes into this, or what is part of the diesel particulate, you might see in publications or other areas. If you do research, you see the solid fractions, elements, carbon, ash, and I'll get to that ash in a minute. Soluble organic fractions, organic material. So just looking at the slide, just hypothetically, you're an engineer, you're a chemist, you know what comes out, and those are things that you're working on to try to reduce, okay? Now, composition of diesel particulate. Metal ash, I put it big in there. Compounds derived from lubricating oil additives and from engine wear are also a source of solid material diesel exhaust. Ash emissions. They are a great concern if you're a developer of diesel particulate filter material. I went through that whole stage with, when we started with the diesel oxidization cats, the diesel particulate traps, and so on and so on. And it's been quite a journey. All right? And this is part of the journey. So realizing that we're going to have an issue, so we're going to get into these particular filters. Well, we're going to have an issue because we are going to get some ash and we're going to get some products in there that's going to slip through the engine. And one of the issues is the oil. Okay. So the goal is, if you were trying to make those cats in the day, okay, those filters, the goal is to reduce the ash, to extend the maintenance intervals on diesel particulate filter. And those of you who were around in the day, you know that happened, okay? We went through a whole slew of different types of oils, and it's still more so important than ever, but it was very important. When we went through that stage, we wound up with the CJ4 oil, and I'm not making an oil class out of this, okay? I just plucked a few things in here. You can read through it. Designed to meet 2010 model years on Tier 4, blah, blah, as well as application with diesel fuels ranging in sulfur content up to 500 parts per million. And I'll get to that in a second. However, the use of these oils with greater than 15 parts per sulfur fuel may impact exhaust. So the sulfur fuel became an issue also. And then you got, why do you want to use that CJ4? They're effective at sustaining emission control system durability. Basically the selling, and it's not just a selling, but they had to go into it. Protection, control of catalyst poisoning, particular filter blocking, engine wear, and so on. Then of course we got the CK4, and now today, okay, make sure you put in manufacturer's recommended oil. I'm starting to see a lot of deviation for years. I was very comfortable, just go out there and get the 1540 oil in there, okay? But now things have changed again, okay? For example, there's an APA FA4, and but all of a sudden we're in the kind of middle area where we can make mistakes. You get a vehicle in, and if you don't read what the recommended oil is, now I'm talking about heavy duty diesels, and where you see that XW, it could be a 530, could be a 1030. It has to be specially formulated, okay? And if you notice, I put in red, they are not interchangeable or backward compatible with API CK4, okay? Look, the bottom line is I would not want to be involved with any engine emissions issue due to wrong oil. If there's ever issue with warranties or anything else, guys, some of you guys might take oil samples. You know how easy to do is figure out what went in, what shouldn't have gone in. And again, it's cover thy ass. Composition diesel particulates, health concerns. You see a few slides in there, and that's one of the main reasons. They look at the cost of health-related problems to emissions. They're into billions and billions of dollars, and that's why we got the regulations, okay? I got size does matter, and you can take your time, go through it. I don't want to spend too much time, but it has a lot to do with the size of microns, what can get into your lungs and what will affect your respiratory systems and so on. And of course, because we had those emissions regulation, we also get involved with what? Emissions programs. Not every state has an emissions program. Okay, I know in California, you guys are heavy into it, but even like I'm from New York State, we have an opacity testing in more of our New York City area, whatever, 713 barrels. The rest of the state, it's kind of random checking for opacity. And to be honest with you, most of vehicles today, this is my again, 2 cents, you don't see that many smokers out there. I think random would have sufficed. If you see that guy smoking like crazy out there, that's the one exception to the rule. Me personally, everything in these diesels, they're like cars. They're OBD type of strategies, plugging into OBD, connection, whether it be a medium duty car, heavy duty, you're going to get all the answers and everything because you got a mirror image of what we're doing with cars. Now, this I was a little surprised with. This we've known for years, okay, that you're technically not supposed to mess around with it, and what happens is there's a lot of defeat companies out there, they'll defeat the emissions portion of it. And if you ever Google online and you go deep enough, they'll actually advertise online, okay? So they're out there, but I believe last year before, there's some trucking companies, some shops, they got some millions and millions of dollars of fines. So they're looking at that, to be honest with you, very, very, very seriously, okay? Testing, I want you to know that I have gotten into areas that are a little deviate from actually working on them and doing that. I have gotten in with some companies, like if you see the Turbo 3000 over there, put them through some rigorous tests, using machines like that, okay? And it's been well worthwhile. The deeper I got into emissions, the more I learned. Okay. Now, emission, I could have spent more time on that. Give you some explanations. Like, let me back up over here. Like if you see that Turbo 3000 in there's a perfect example. A company came up with this little device. You put it in line with the fuel, and I can't do it here. I have it, I would wrap that thing. You'd also hear some harmonics, like a tuning fork in there, where it would break up the molecules of fuel and everything else. The sad part of it is I put it through some tests. The company, a lot of people loved it. They were buying it all over the country. And believe it or not, about a year or two afterwards, Cummins wound up with a similar device that they started putting in their engines. But I digress here. Now, reduction. How can we reduce? There's basically 3 different ways. We got pre-combustion, EGR turbocharging, clean fuel timing, complete combustion. Then in the combustion process, we also have electronic fuel injection, high fuel pressure, swirl technology in the pistons and so on in the combustion chambers. Now, the thing we're going to concentrate on today is more on the post-combustion, okay, the diesel oxidation, CAT, the diesel particulate filter, SCR, some call it DPF or trap, whatever the case may be. But all 3 of those, to tell you the truth, they all rely on computerization. That was the game changer, because I remember in the day when cars had computers forever and ever, okay? And then trucking manufacturers were thinking about getting into it, and all you could hear was like, oh, it ain't never gonna fly, computers ain't gonna work, this is BS and all this stuff. And lo and behold, when we got into it, guess what? The engine's running cleaner, they last longer. Less emissions coming out. I mean, it was a win-win-win. And for the companies that were the naysayers, they woke up one day as they started to get these newer vehicles, and their average miles per gallon rose, I mean, tremendously just by going into computerization. So, and this goes back to what I first said. Give us a challenge. We will all day long overcome it. This country has some very, very good people. Okay? Now, computerization enabled the following to occur: diesel oxidation, diesel particulate filter, variable geometry turbocharger. I'm going to cover that next month. Common rail diesel fuel injection, cooled EGR, going to cover that next month. Okay? And of course, we all are going to head into the diesel exhaust fluid area. We'll spend a little time on that. So just, even though I'm not doing turbos, but the big game changer was, turbos going from just a simple turbo and then starting to vary all the exhaust gases coming out, helping to create back pressures. They really helped. And again, there's a few versions. Like I said, I'll get into that next month. Now, another huge game changer was this common rail high pressure fuel injection. High pressures, and I started low, 23,000 PSI, and of course more and more each year goes by. Multiple injections per cycle. Why did we go for that? That's another method of trying to reduce NOx. Okay, you're basically going to wind up with a finer mist, even distribution cylinder, more complete burn. Okay, so let's talk about diesel combustion. As the piston nears the top of the compression stroke, this is what actually happens. High pressure fuel is sprayed into the compressed cylinder contents. The content is primarily air, of course, along with some residual combustion products. We already talked about that. Now, with that injection pressure, orientation of the intake ports, piston motion, piston bowl shape, which they all were an enhancement, turbulent mixing of the fuel and air. Okay. It goes through phases. You start out with what we call an ignition delay, starts after initial injection of fuel, continues until the initiation of combustion. Then you're going to have a rapid premix burning of the fuel and air mixture from the ignition delay period. And of course, we're going to what we call a diffusion control burning, which the fuel burns as it is injected, diffuses in the cylinder. So as it's coming out, you can almost visualize the fuel coming out and the piston burning, going down, going down, going down. Talk about a nice controlled burn over there. So very small amount of rate control burning during the expansion stroke after the end of injection. Yeah. Engine speed, load is controlled by the quantity of fuel. Look, again, you're compressing air, and the more fuel you inject in there, of course, you're going to get more speed. You can visualize that. Okay, and I already mentioned the cylinder's contents are always fuel lean. Time available for combustion, proximity of oxygen determine if fuel droplets are either completely or partially oxidized. Okay. And what happens inside, again, that we can't see, we're going to have those high temperatures. That unburned, non-oxidized fuel is what we call pyrolyzed. It's basically stripped of hydrogen to form elements of carbon soot. And the soot keeps coming up all the time. The soot leaves the engine as a component of PM emissions. And that's what we're trying to tackle. And there's other compounds that are present in there, Now, oxides of nitrogen, NOx, primarily in the form of NO, nitric oxide, they're going to form during a high temperature. The relationship with NOx is you need high temperature. No ifs and buts about it. That's when you're going to form and you're going to generate and you're going to make NOx. Okay? And the reaction is forming the NO and some of NO2. The majority of NO2 formed during combustion is rapidly decomposed. Thus, most of the NOx emissions takes the form of NO, but you're still going to have NOx coming out. Some organic compounds from unburned fuel, lubricating oil consumed. We talked about the oil and stuff by the engine can form in crevices, cool spots. Just think about the piston going up and down. You have your rings in there, you got the lands in there, you know, you got leakages, and not everything is perfect in today's engines yet, you know. So you're going to have some bypass. Then, of course, we talked about ash from oil combustion also contributes to trace amounts to PMS. Diesel after treatment, what are we trying to do? Particulate matter, NOx, hydrocarbons, carbon dioxide. That's in that engine. That's what we're going to create. The after treatment focuses on 3 areas of emission control. We're going to try to get rid of the HCE and CO. We're going to try to reduce NOx. And of course, reduction of the particulate matter. How do we control diesel emissions? 2 ways. The source, modifying engine design. You know, we already discussed about fuel, you know, changes in the piston areas and so on, the turbulences. And of course, add-on controls. Treat the diesel exhaust. History lesson. 2002, 2004, emissions regulations targeted NOx levels. So pretty near, not all of them, but pretty near, most engine manufacturers use some version of EGR to meet those levels. For 2007, the EPA focused on particulate matter. Now, the 2007 is that magic year. It doesn't matter if you got a pickup truck with a diesel or whatever, you know, those trucks are going to come with a diesel particulate filter to trap the soot in the exhaust. And then along came 2010. The focus is back on NOx again, okay, because the EGR just didn't do enough. So we're going to lower the NOx, okay. So those are the changes. And that would be, believe it or not, a good 90% reduction from pre-2004 levels. That's huge, you know. Now, Treatment System 101, exhaust after treatment systems. And most of you heard, I see one. I just happened to look over for a second here. I tried to look over, why did we, VGT cannot be serviced, replace only? I'll get that into that turbos next month. I run into some problems. A lot has to do with, you know, the control of it and, you know, calibrating and everything else. And I'm not quite sure at what level service you are talking about, you know, but there's some intricate parts inside there. And I've had some luck, you know, with some of them, try to get either the vanes to move or that whole intersection to move a little bit. Carbon is a huge issue with that, but I'll get into that next month. So back to this exhaust, they're classified either active or passive. Active systems contain actuators that must be controlled electronically, provide emission reduction. Passive, they're pass-through. Just think of the word, pass-through. Systems that have no actuators, therefore no need for electronic control. And I'll get a little bit more into between the active, and it has a lot to do with regeneration also. So now, exhaust after treatment systems. Oh, I already did that. Or did I? Hold on a second. I got digressed. Passive system pass through, therefore no need for electric controls. All right. I'm only comparing this a little with a gasoline engines, because we really started with the gasoline engines with all the cats and everything, and you're looking at three-way cat, typical gasoline engine system. You got the three-way cat, okay, and you had a few sections in there, you know, sections to reduce NOx, section to get rid of hydroxidized hydrocarbons, carbon monoxide, and you see on that slide a lot of precious metals and stuff. So I wanted you to see this gasoline engine concept here. Okay, now the three-way cat utilizes the operating principle of non-selective catalyst reduction of NOx by CO and HCs. So it's going to use the CO and HCs as a benefit, and your oxygen sensor to this back and forth. It stores oxygen because get rid of NOx. You go a little bit rich because lean is what NOx is loving, you know. So we had a method of tethering back and forth at stoichiometric, and we were able to accomplish a lot, okay, requiring that the engine operates near stoichiometric air-fuel ratio. Oxygen sensor combined with a closed-loop electronic control system is used to maintain this air-fuel ratio. The diesels, they use what we call a selective catalyst reduction, SCR, for NOx, okay? Gas jobs, non-selective. Diesels, selective. Go back to the beginning. The catalytic converters, they're fitted to both gasoline diesel engines. And absolutely, do they work? All day long. To reduction of exhaust gases, we already mentioned AC and CO. They pass through a honeycomb brick coated with noble metals. You already saw that platinum, palladium, rhodium, which convert undesirable unburned hydrocarbons, carbon monoxide, and so on. Okay. No different in diesel engines. Faulty combustion can cause extensive damage to a catalyst converter. This is why it's important that the engine runs efficiently and the air-fuel ratio mixture is correct proportion. Both car and trucks have those same issues. Why are you replacing some of your cats? Why are you replacing the TPFs? You see the pictures over there. Foul, clogged, broken. Now, the emission control catalyst. Oxidation catalysts were first introduced in 1990s to the diesel fuel cars in Europe. And of course, heavy-duty diesel buses, some truck engines in the United States. And then they've been around a while too. I throw in a little 2 cents here. Underground mining, used them since the 70s. So what is this DOC? Let me shut that little picture off over here. DOC and exhaust catalyst assembly are 2 types of passive after treatment systems, meaning you don't have to do anything. DOC systems are not new. They're used on some light, medium duty engines. They're used to promote the oxidation of many pollutants, COHC. Go back on your list for those soluble organic fractions, okay, into less compounds such as CO2 and H2O. Typical configuration consists of a deposit of active material, just like you would have on your car cats, you know, on a substrate. The substrate is configured as a monolithic honeycomb. Oxidation catalysts rely on precise blends of precious metals such as platinum and palladium. So we're basically, if you're comfortable with cars, you're going to do the same thing, okay? You're going to do the same thing with diesels. I'm trying to look over at the chat too. DOC combined with exhaust filter. Okay, by themselves, the oxidizing catalysts. Again, we're talking about the diesels. They do a poor job of oxidizing particulate matter, and that's the reason we have these exhaust catalyst assemblies. Basically, you're going to assembly that consists of the DOC, diesel oxidation section, and of course, we're heading towards the exhaust gas filter, okay? Some of you might call it a trap, okay? More commonly known as the TPF. Okay? Now, this is just basically showing, because one of the other issues I'm going to point out is that who does what where. You get by the truck over here, and all of a sudden now I know what a DOC does, I know what a particular filter does, what does a SCR. You're gonna have to get used to the first thing you need to identify is what section is where and how, okay, and we'll get into that. So we're starting usually, if you're looking at the right, DOC, TPF, and then finally you see the doser over there for the SCR. Advantages: durability, maintenance free. There's a low pressure drop on those, meaning that filtered air, when it goes for a filter, I'll just give you an example on the air intake side, believe it or not, you're going to have an air pressure drop, okay? And an engine has to breathe freely. So the less drops you get, and it can't breathe freely, it also has to exhaust free. So the more less of pressure drops you have in the system, the better that engine is going to breathe and run. Okay, simplicity. However, there are some disadvantages now. They definitely are temperature dependent for performance. Okay? And of course, if you have loss of activity due to poisoning and or thermal problems, you're going to get into what's called sintering. You know, it's going to destroy that cat or filter. And that's an example over here. Temperature, if you get too much temperature, it's going to sinter, and of course, you're not going to have the good active material, and you're going to have pressure drops. DOCs at high temperatures provide a very effective control of HCCO emissions with reduction efficiencies. Every time I look at it, 90%, that's huge, guys. That's huge. I think they've done a very good job. The high conversion is realized through the use of noble metals. We already walked through that. These same cats are also used for particulate matter conversions with an efficiency in the 15 to 30%. Common to all emission control catalysts, dependency again, that conversion efficiency you need to relate to the temperature. And I gave you some example. Conversion is near zero at low temperatures, 212. Conversion increases slowly at first as temperature rises 302. And of course, once you start getting higher and higher, you're looking at 572, your conversion really becomes great on these things. Okay? Now, some catalysts do have a temperature window, so increasing temperature may increase the conversion efficiency only up to a certain point. Temperature increase beyond that window causes a decrease in catalyst conversion. So those people that make up these engineers, these designers, they had to weigh in a lot to find that perfect balancing act. Okay? This type of conversion, utilizing a conversion temperature window, is typical for selective reduction of NOx by hydrocarbons or ammonia. Emission control cats, oxygen is ineffective reducing NOx. Diesels are lean burn. We already went through that. For this reason, the three-way cat cannot be used for NOx control. However, CO and HEs can be controlled with high efficiency by today's catalyst technology. Okay? Note that SCR, I keep saying that, is utilized for the reduction of NOx, and we'll get into that. Summing it up, oxidation reactions convert COHEs and HE derivatives, didn't even put that list down, into CO2 and water vapor. Key to reducing particulate matter, sulfate, was the reduction of sulfur in fuels. You guys remember going through that? All of a sudden, we had to reduce the parts per million, so the fuel industry had to get into a change also. Everybody follows everybody. You know, it's kind of like, you know, did we put the horse before the cart or the cart before the horse? And even today, they left that little kind of loophole. You know, if you're off-road or, you know, if you're in a farm, you could use that higher part per million on fuel, you know, so sulfur, that is. So diesel, let's get into diesel particulate filter regeneration. The DOC provides additional heat during oxidation period, additional oxygen to aid in regeneration of soot in the filter. Okay? That filter portion of it now requires 1100 degrees heat to convert soot into CO2. Now, I'm not talking about the DOC. The DOC is helping the DPF. Okay? I threw that in again, just a little reminder, because I'll be honest with you, when you see the different configurations of these systems out there, the first thing you want to find out, well, which is doing what is doing, because I now know what's going on inside there. I know there's a DOC, there's a TPF, there's a SCR, but which one is what, okay? So that's the big issue. It's not an issue, but that's the area you need to get comfortable. And I'll show you a slide in a minute too. Okay? Now, diesel particulate, let's talk about the filter. We already talked about it. 2007. Anything after 2007 has to have the DPF. And basically, what are you trying to do? You're trying to remove the soot using a porous ceramic media. Capture particles accumulate on media. TPF must regenerate. We talked a lot about that stuff. But what I want you to, let me go back. I tried to get my little pointer thing. You see these plugs in here? Okay, so unlike the cat where you pass through, this filters, there's a reason they call it a trap. You got plugs. Every other one of those has a plug. So to tell you the truth, if you took one of those off, okay, and you separate it from the housing, one of the first things I would look at, do I proceed any farther in the cleaning process? I want to make sure that the plugs are there. Every other one you can see here is a plug. If they're missing, I'm not quite sure how effective this trap will be. So that's my 2 cents again. Now, basic passive regeneration. Normal high evaporation will generate enough temperature to provide the heat to clean the TPF. Under light load, exhaust temperature too low, fuel is added to the exhaust. Okay? And there's systems that add fuel to it to cause a chemical reaction in the DOC before the filter to add additional heat to clean the filter without driver input. Okay? Takes approximately 20 to 30 minutes. Then, of course, you could get into a situation where the driver requests for regen when vehicle is stopped. That it's like it wasn't, the conditions weren't right, so periodically the driver would have to kind of like the lights would come on, it's like put it into a regen. So if that's the case, it should be done outside the building. And what happened was, you say for example, if you have a metropolitan area with a lot of buses and stuff, when these things first got out, at the end of the runs or whatever, periodically bus companies would actually set up some schedules where somebody would, while it's not driving, while it's waiting for the next day's run, put some of these vehicles into a regen. Okay? And that's exactly what the rear world now. Nice if you're a fully loaded line haul, you're going to have your temperatures, everything's perfect. But what about the stop and go operation, cold weather? You probably require active regen. Okay. Active diesel particulate filters perform the same function as passive TPF. Active TPF does not use heat from the engine exhaust to oxidize the trapped PM. Better suited for engines with high PM emissions. So there's a few different systems out there. Okay? Most common methods: electrical regeneration, injecting fuel to provide additional heat to oxidize. So there's different ways of doing it. Then you got automatically on board the vehicle when specified back pressure is reached, DPF regeneration occurs. Also utilizing indicators such as warning light alerting driver that regeneration is needed, requiring the driver operate to initiate the regeneration process. Okay. Now, that hydrocarbon injector driver module, okay, and this is a dormant sells those. This one is shown used by the Volvo Mac integrated dosing system, typically located. Okay. Let me just put this here. Let me get my camera over to me a little bit. Okay. This is what this looks like. Now, what happens basically is, believe it or not, this uses a secondary air from your air system, okay, to open up the valve to inject fuel in there. So my point being with this is that your secondary air pressure is huge. The clean air is huge for this thing, So just because of the emissions, let's relate the air with this. If that makes sense, okay? And they will fail, okay, if they get plugged up prematurely with soot and stuff. So now also you do have a pressure regulator that goes along with this also. I'm just going to hold this up, zoom in on that. Okay? So believe it or not, this looks just like a pressure protection valve or regulator in a regular air system. But this one's designed for the fuel injection pressure. Okay, so I just wanted to point that out. And of course, this is from a Mac, and here you have example of a dosing dosing injector, hydrocarbon injector, okay? And if you notice, if you see it close enough, failed because of soot carbon buildup, okay? Just throwing a few stuff out there. And of course, now I lost my clicker. We'll get back to this. Now, I might run a few minutes late. I know we're gonna. Okay? You're gonna get into off-board filter clean. If you gotta jump off, just so you know, this will get posted, guys. Okay? And I was straight up front when I said that sometimes, you know, I try to cover a little too much, but that maybe that's more of my live trainer portion of it. I actually try to make it a training thing, not a quickie little here, put your wrench here and just turn it and woo, 10,000 hits on YouTube. That's not what I'm about over here. We'll get into onboard a little bit more now. TPF pressure sensors. So far we talked about the canisters, the filters. This sensor is an input to the PCM used to measure pressure before the TPF pressure sensor. It is a differential type sensor that's referenced to atmosphere pressure, similar to what you might use on a EGR system. The TPF pressure sensor is used by the PCM to monitor the amount of exhaust pressure produced by the TPF. Active generation is performed when the reading reaches a certain point. I put this together just to give you an idea. You see over there the DOC, you see the TPF, and you can see what's involved. Temperature sensors, delta pressure differential sensors, used to measure pressure differential across the PF. And why do we do that? And you can see that on your scan tools and stuff, right? Large pressure differential indicates the filter is restricted. So depending on the scan tool, like I have a Can-Do, I have a J-Pro, and it winds up doing a pretty good job. I can look what's going on inside there, but regardless, what I see, the computer's seeing that too. Just like your OBD2 cars that you have out there. You got the exhaust temperature, EG sensors, inputs to the ECM. They measure temperature, of course. You know what? Got to get comfortable with your systems. Some systems might use 3 or 4 of them, you know. Some, again, you know, they're out there, and that's what you need to get comfortable. Here's an exhaust gas temperature sensor. So again, another product. The reason I put this slide on over here is if you look over here, if you look any kind of a sensor, you know, the oxygen sensors and stuff, so you're pulling it out of there, and guess what gets stripped? The threads get stripped. You're in a hot environment, and I know you guys know what I'm talking about. You know, I mean, that thing comes out, you're holding it in hand, everything's stripped. Okay, what Dorman did was they came up with a bung repair kit, okay, in case it is damaged during repair. So I think that's a pretty nice concept to sell it as a kit. Exhaust bellows. Joint wear. The exhaust bellows and clamps are huge, okay? And the reason they're huge, let me turn this on over here real fast. I'll move over here too. Like I said, I could spend hours on this stuff here, okay? But the nice thing is, if there's a weak area over there, you know, they came up with a nice little, let's make it, beef it up so we don't have issues. Let's beef up the clamps. Let's beef up all this stuff, okay? So all this stuff is available, and sometimes better because we learn from our mistakes. So I'll get back on board on this real fast. And the reason is the role of exhaust clamps and gasket. It's a stupid portion or component that nobody thinks about. They will wear, you guys know I'm preaching to the choir here. If you work on this stuff, you try to get some of them off, they're frozen there, and then so on and so on. But the problem is, if they're leaking, they allow cold ambient air into the exhaust. Temperature sensor is going to pick that up, and it's going to lead to a low inlet DPF temperature. And again, low temperature, poor reach-in, and so on and so on. So please, look at that in your handouts. So why would you care about sensors? What is being used out there? Absolutely for diagnostics all day long, okay? How about as a requirement because of OBD2? heavy-duty trucks, OBD2, right? If you ever go into the heavy-duty portion of the OBD2, you'll see a mirror image of the cars. You'll see the requirements, the monitoring, the thresholds that will kick a code, and the similar idea of, how many times do you get an active code, how many times do you see a failure before it becomes active, do you get independent codes and so on. But anyway, here, just an example, okay, non-methane hydrocarbon, conversion efficiency threshold, NOx catalyst, conversion efficiency emission threshold, and it goes on, absorbers, PM filters, upstream exhaust gas sensors, downstream exhaust gas, NOx sensor 1, NOx sensor 2, PM sensor. So your OBD2, if you get comfortable with that, you get some pretty good strategies that you can utilize to help you out. Why worry about NOx? Again, we already covered it. It's created in the cylinders, high temperature, ground level ozone. How can we reduce it? Chemical reaction, lower combustion temperatures. Okay? And again, I'm throwing it in to keep in mind, today's diesel engines are 90% more cleaner than diesel engines of 2000. Okay? Now we're going to get into everybody's favorite, the SCR. Okay? Unlike HC, CO, PM, NOx cannot be removed by oxidation. NOx must be reduced. How? Accomplished by combining HC and CO with NOx to form nitrogen, CO2 and H2O. How can we do that if the diesel engine is lean burning? We already went through that. No excess amount of HCCO to help that process. Okay? This requires help from an outside source. SCR system introduces a urea. It's an aqueous ammonia into the exhaust stream of the engine before the catalyst bed. Reductant introduced into the exhaust stream creates a stoichiometric environment. This allows NOx to be reduced on catalyst. And please, guys, try to, if you can stay with me, stay with me. If you got to drop out, again, it's going to be online, okay? The reductant introduced into the exhaust stream, that creates a stoichiometric environment somewhat. This allows NOx to be reduced on the catalyst, okay? Unlike the car. Now I'm going to skip through that. Now, this is a nice one, okay? This is from Dorman. I'm going to click on this. What is an treatment system? Now I clicked on there. We got an EGR cooler, okay? That's been around for years, helped reduce NOx. Okay? You're going to get involved with NOx sensor and an inlet. You're going to have a hydrocarbon dosing module. We talked about that. Okay? You're going to have exhaust temperature sensors. You're going to have a diesel oxidization cat. You're going to have your diesel particulate filter, and look the way it goes, in series, how it starts. You're going to have a differential pressure sensor. It just popped up on top, in case you missed it. You're going to have the diesel exhaust fluid module, and of course, you got your selective catalyst reduction portion of that system. And you can see the way it flows too on this one here. And of course, let's not forget another NOx sensor and clamps and gaskets. NOx decomposition catalyst was recognized in the 1980s. It's a while back. Okay? SCR reduction NOx is realized if a reducing agent is injected into the gas upstream. I'm going to go fast on this. The main advantage SCR is its high NOx conversion. So it definitely works, okay? Disadvantage, of course, when you first got these vehicles, 2010 on, you probably paid a higher price for that vehicle prior to that, and because of all the stuff that had to be added on, okay? What is it? Technology injects urea. We already talked about liquid redundant. What is that urea? Okay, it's a solution made up of purified water, 32.5% automotive grade urea, used as a carrying agent. For the ammonia, needed to reduce the NOx emissions. And definitely the biggest issue that when this first came out, boy, the quality. I mean, it really had to be controlled. So if you want your system to work, you've got to pay attention to quality, purity. Availability isn't an issue anymore. It was in a day, you know, transportation, distribution, dispense equipment, package dispense equipment. Most of the time, you know, if you're a huge fleet, you got to make sure that you're dispensing it from big to large. DEF, and I'm going to tell you right now, I mean, it looks funny having a big sign up there, DEF only. You can have all the signs in the world, and I'll always get some vehicle comes in, and all of a sudden somebody puts something else in there, and that can get awful pricey, okay? Here, real fast, I'm gonna do something. This is, I'm gonna shake this up, okay? It's DEF, but somebody did a mistake. So I'm going to shake it up. It's all shook up over here. I'm going to leave it sit here a minute. Okay. Verify that it's there. Mark the spot, Bobby. Okay. So now I'm going to get back to this. Okay. Now what happens that urea, I'm going fast, is hydrolyzed to produce the oxidizing ammonia in the exhaust stream. Heat breaks the urea down into ammonia. Okay. Little reminder, year old 2007, things changed in 2010. Doesn't matter if you have a pickup truck or whatever size vehicle. Okay? You're regulated to that. So let's review real fast. Exhaust flows out of engine through DOC, then into the TPF where the PM is collected on the walls of the TPF. The collected PM is oxidized, removed from the TPF. We call it regeneration. During sufficient exhaust temperature operating conditions, the TPF is continually self-regenerating. We call it passive regeneration. On frequent occasion, active self-regeneration is required. Okay. Storage and handling, I'm not even going to go through that. You got it in your handout, okay? But again, everything is regulated. EPA requirement, tamper-proof system, progressive warning, audible visual indicators, engine D-rate, no start. And of course, if you happen to work on these vehicles, you know exactly what I'm talking about when these things come in. Okay? Without urea, the vehicle will not run. So consider it another source of fuel, basically, if you want to look at it that way. Typical system, you got a reductant or diesel exhaust fluid. You got a tank to hold it. You got a dosing module. You got a reductant pump and heater assembly, reductant tank heater sensor assembly, reduction purge, NOx sensor module, and so on. It's in your handout. But I will slow down for a second. There's 5 main states to this, and this is something you probably should try to get comfortable with if you're doing diagnosing, is that because you can watch this stuff, you can hear this stuff. The beginning is key switched on, but no start. System initializes, goes through a self-test. That's when the priming stage begins. Now you start the engine, exhaust temperature is higher than preset value, pump starts to build up constant DEF pressure, dosing valve goes through a test, again, self-diagnostics, okay, the DEF pressure should decrease, should recover quickly, ends with hopefully DEF pressure okay, dosing valve is okay. Okay. And you can monitor on scan to available. Definitely you can monitor by a Cummins Insight. Okay. Then dosing. The dosing state. When system is successfully primed, ready to dose, pump runs continuous, maintains system pressure, 130 psi, dosing valve is closed, no DF spray into exhaust. When the ECM determines need to dose, it's going to energize the solenoid with a pulse width modulated signal. Okay. And of course, it's going to be delivered into exhaust by impulse injection. Okay. Required conditions, and again, don't expect it to happen unless you meet these required conditions. So again, it's a good thing to know. Then of course, we all know about the purging. You turn the key off, dosing system will shut down with a purge cycle. What you're trying to do, prevent DF from being left in the system. Okay? And you can read that on in your handouts, okay? And of course, heating state. Now it's very, very cold outside, and please read this, slow it down in your handout, okay? it's going to go through that stage, okay? And I put a little note, if ambient conditions continue to be cold after priming, the DF controller will command a maintenance heating feature on some of these systems, okay? And this information is from Cummins. This is a Hino over here, and you see over here a refractometer. Let me switch, I'll show you real fast. You know, this wound up being very, very nice. Shit. Excuse me, drop that refractometer. You get a little bit of fluid in there, you point it up in the sky, light I should say, and of course what you're going to wind up having is you're going to wind up having on that slide that you see the urea scale. And it's helped us out quite a bit because unfortunately, you know, sometimes somebody does not put the best of DEF in. Maybe it's been in there forever and ever. Truck's been sitting around. And again, of course, you got the occasional somebody that screws up. And of course, here comes the codes. It's going to go into D-rate, you know. And then, of course, we got to do the fix. Eh? Reversing pump. Again, go through it. Now, Cummins came up with a nice system, the UL 2.2 dosing system, because a lot of, if you know about your SCR, you're going to have some coolant lines in there too and all that stuff, return lines. Now, this is what it looks like in the real world, okay? You got a supply line, suction line, DEF pump filter. Now, I kind of took their kind of cell sheet, okay? The UL 2.2 continual presence of urea within this unit prevents doser crystallization, and that's huge. I got pictures of that crystallization all over. The only liquid-only dosing system to offer freeze robustness. No power requirement after key avoiding priming issues. So there's a lot of benefits. So, you know, crystallization here. Zoom in on that if you can. There it is. Okay. I mean, I've had chunks like this once it collects in the mixer and stuff. And of course, you're going to have a lot of issues with that. We're almost there. Okay? So this is another product from Dorman. Function covers joint between lower muffler housing, SCR, and so on. Okay? Filters, they're huge. Okay? Please go through your handout. Okay? There's your dosing module. Injects the reductant DEF into the exhaust, water cooled, reductant exhaust. Quite often there's a mixing system. Here's a NOx sensor. The NOx sensor is like, you know, wow. Controls a NOx heater circuit. It's got a heater circuit communicates to a PM and a PCM. I'm trying to get one in my hand. So you have it in your handout. Okay. So let me get my thing back again. Stupid little stuff, guys. So this is from Dorman. They have a hard aftermarket, you know, NOx sensor like this. I have an advantage to be able to hold some of these products in my hand. But the one thing you want to make sure is that all of us, we start putting this in. Don't do this. Okay, and make it tight. If you look over here, you got wires over here. Don't do this. Okay, bottom line is it's a stupid stuff. Back up a little bit. Okay, maintain a nice loop over here. You don't want to get crap trapped in here, moisture get in here. And of course, you guys that work with this stuff, you know all about the electrical issues. Okay? And a lot of times just trying to diagnose it, pull it out, and if you look at the tip of that NOx sensor, it's almost like an oxygen sensor. Okay, you got an O2 pumping section and you got a zirconia section in there that separates the NOx and everything. Now, sensors have an internal heating element, allows typical moisture to be evaporated. Okay? Again, section of chip separates oxygen from NOx. Second, operates a catalyst to break down NOx into nitrogen oxygen. So, 2 per vehicle. They rapidly reach operating temperature, just like you want to do with your oxygen sensor. Okay, similar zirconia oxide chamber. Okay. This one here, and that's what I was talking about. Here's a 2014 Hino, and they call them a, you know, single unit kind of setups, and you see them a lot out there. You know, it looks like, you know, one is on top of the other, and that gets hard trying to figure out, well, which one's the cat, which one's the DOC, which one's the SCR, what are all these, you know. And if you work on 10,000 different models of vehicles, try to get that information, but you need it. And of course, all these trucks have some kind of label. I'm trying to be funny. I wonder how many people read these labels. Right? Notes from Cummins, just so you know, vehicles with Cummins engines. Cummins supplies the after treatment DEF controller, DEF dosing unit, DEF valve, and SCR catalyst. Vehicle manufacturers supplies the DEF tank, DEF lines, DEF tank. Temperature level sensors. After treatment DEF dosing unit pumps DEF from the DEF tank to the after treatment DEF dosing valve. The DEF dosing unit is electrically heated and contains a filter that's maintenance free, except for that previous one that you will too. The after treatment DEF dosing valve is coolant cooled, sprays DEF. Okay? And again, you got those in your handouts. Please go through it because I got to start winding it down. Okay? So I put a few notes in from there. The last few things are about ash cleaning, and I'm winding down. This is a preview of next month's Lunch and Learn. I'm going to get into turbochargers. I'm going to get, you know, turbochargers, but I'm also going to get into looking at some sensors. You know, how do you know, figure out, do I have a bad temp sensor, and so on. Any questions? I see one question. Does the refractor meter specific? No, the one I have. Let me real fast come back to this. The one I have over here, it does two different things. It does do antifreeze, and it does have that scale. If you go back, you look at that handout, and it has on that, I believe it was on the upper right corner, it's for the DEF, and it actually gives you the range of what you're looking for. And I'm quite sure you can get them for specifically for that, but the refractometer is really great, you know. So any questions? I gotta put this other slide on here real fast. Okay? If you, sorry, Bobby just reminded me, zoom in on that real fast. Okay? Needless to say, if you stayed with it, okay, you see how it changed. It's separated, just like gas does with ethanol and stuff. If you have water and crap in there, I got bottles of that stuff too. But anyway, let me real fast, before everybody leaves, real fast, take a snapshot of this QR code, okay? And if you do that, do me a favor, fill out a quick survey. Hopefully you like this class. It helped out for you, and it keeps us going, okay? Now, I'll go back to me. I thank everybody for coming. I really hope to see you guys next month. Like I said, this is a lot of information we're trying to put into, and look for this to be online. They're gonna post it online. I think Chi said probably by this weekend or so. He's all over the country doing a lot of trainings. So look for it online on YouTube. And thank you again. Stay safe out there, guys. And I mean it. Thank you.